Hey, how's it going, guys? So I'm going to show you an example of how to answer a question with a normal curve, and I'm even going to go into using a z-table. Okay, let's take a look at an example problem from this chapter that would say something like this. Let's say we're given some SAT scores. Let's say they tell you the average, the mu, was 500, and the standard deviation was 100. Make a picture of the model and determine what percentage of students scored between 450 and 600. Okay, let's take a look and see what we can see. Start by making a normal model. The mean is going to go right in the middle. Okay, and then I added that number 100. That's the standard deviation. I added it 3 times, and then I went back to the mean, and I subtracted it 3 times. Okay. Now from this middle point, I'm going to go up a few boxes, and I'm going to create that curve shape by making 5 dots. If you have questions on how to make it, watch my other video on how to make a normal curve. Okay, so I kind of just traced it out here. That I these scores, so 0, 1, 2, 3, -1, -3, those are my z-scores. I made a label calling it SAT scores. I have my capital N, parentheses 500, 100, to show that this is the normal model, SAT scores. And then they want to know what percentage of students scored between a 450 and 600. So I'm going to mark that off and let's see. Okay, so we got to find the area of this shaded, and we're kind of running into some trouble because we know this little section over here is 34%, but this little half guy right here, we're not really quite sure. So we're going to go ahead and find the z-score of 450, which I believe to be about a -1/2. Okay, but we're going to find that z-score. I'm making little notes here that I went from 450 to 600. I'm going to go ahead and find that z-score. of where is 450. I know this is 1. Let's see if we can find. Okay. Okay, so my z-score for the left side is 450. Sorry, my z-score is negative 0.5. So when I do the z-score equation, you take the value that you want, okay, subtract the mean, divide it by the standard deviation, and I got negative 0.5. Let's see what we can do with that number. And right now I'm not really quite sure, so I'm going to go ahead. I'm going to do the other z-score, and then I'll show you what to do from there. Let's find the z-score of 600. Which that kind of confirms, right, that 600, the z-score, was 1. Okay, so from negative 0.5 to 1, we got to find what percentage is that. So there's a few options that we have. I'm going to show you the easiest option, the first option I'm going to take, and I'm just going to show you that one because it's the best one to do. It involves a little bit of critical thinking of maybe some concept back in geometry. Okay, so let's see how we can approach a problem just like this. If I go to a z-table, this negative 0.5 is going to give us the area or the percentage to the left side of negative 0.5. All right, and then if I was to find the z-score, look at the z-table and check out at 1, okay, at a z-score of 1, it's going to give me the left side shaded all the way to 1. I don't want that. I want that gap between them. So what you're going to do is you're actually going to find both of those values, and you're going to subtract this one from this one, and what you'll get left over, okay, if I was to subtract, watch this minus that. What you'll find is you'll get the gap in the middle. So you take this big one, let's switch. But if you take this big number, you subtract this other number, you're going to get the space in the middle of that. Okay, so I'm going to go ahead and look up from the z-table how to get those numbers. So let me show you how to do that. All right, I am going to all over, okay, that z-dash table. Look at z-dash table, and it would give us, here's our numbers here. So all these numbers here represent the left side shaded. What's happening? See that? See that? We're going to go and start with the bigger number 1, which gives us 0.84. Okay, so 0.8413. I'm going to subtract the smaller number. So at negative 0.5, it's 3085. All right, go back to that. Okay. So from here, I want to subtract the 0.3085. Okay, when I do that operation, calculator here. Okay, so 8413 by 3085. And what I get is 0.5328. So one more time. I found the area, okay, using the z-table from 0 or from negative infinity essentially all the way up to the score of 1, the z-score of 1. So from all these SAT scores to here, that represents 84%, or 0.84 is a ratio, okay? About 84% of your scores should be less than 600. I am finding the difference between this one and that one. I've got to subtract the 450. So for the 450, all that shaded region is about 30%, okay, 0.3085. I find the difference, that means you got 0.5328, so about 53% of your numbers, your scores from the SAT fall between 450 and 600. So I'm going to rewrite this as a percentage. So this is just going to be 5328. Then I'm going to, let's write a statement about it. The question is, what percentage of students scored between 450 and 600? Well, obviously, this is just for one section of the SAT, maybe the SAT math, okay? But it kind of makes sense, right? If this whole area, remember we went over this whole area from -1 to 1 is 68%. So the whole area is 68%. And I'm only talking about this smaller area. It makes sense for it to be about 53%. So remember, if you think of like the definition of this normal curve, it's 68, 95, 89.7. So if this little section right here, okay, this whole section right here is 68%. Then it makes sense that 53% is where if we cut it off by a little. Okay, that's one way to check your work. So that's kind of how I work through some problems using this this picture, okay, this model of a normal curve of data. Okay, so if you need help on how to draw the normal curve, watch that video, and I'm going to explain the problems again from the classwork today, from the practice today. So hope this finds you well. You guys have a great day.